Morning, guys. It's Rod with MarineHowTo.com. We're here in my lab/office today, working on my first video on my affordable marine products category. I'm not very good at video, but I'm trying a new format here. I'm sick of typing with one finger, and I've always been a writer, but with only one arm, it's getting to be a pain in the ass. So I'm trying to figure out a new format here. So anyway, I'm a marine electrician. I own Compass Marine Incorporated at MarineHowTo.com. I've closed Compass Marine Incorporated. I can no longer manufacture alternators or bedded tape or any of the products like that. I can no longer work on boats. I had to lay my team of guys off. So I had to close that side of the business. But my brand is still intact and I still know everything I did before, so I'm keeping Marine How To alive. We're trying to anyway. So in this video, we're looking at the Wattcycle 314 amp hour Smart Mini. And smart with Wattcycle just means it has Bluetooth built in. It's got a 200 amp BMS, so 200 amps continuous discharge, and it's impressive. I'm impressed with the quality for the price point. So let's take a look at our lab, how we test things. What we're looking at here is this is what we use to discharge. I use a computerized discharger. I use a CBA5 Pro from West Mountain Radio. Has dedicated voltage sensing. I also use the external amplifiers. So amazing product, computerized. I love it. We used to use these up here. These are Array 3721As, I believe. These are 40 amp computerized dischargers, and they work great too. But this one ties right into my computer, and I can just do whatever I want. Boom, boom, boom. It's super easy. So for high current testing and stuff like that, I've brought my alternator load bank in from the barn where we manufacture the alternators into my lab. But this thing will do 300 amps continuous as long as it takes. It's an industrial design product and it weighs a lot. I couldn't lift this thing up onto this shelf. I had to use my hydraulic cart to get it up on there. It's massive. And the thing I like about it is all the new products are all digital. You have to adjust the load digitally, which I wanted for alternator testing. I wanted a dial. I could just dial up the current from 0 amps all the way to 300 if I needed. And that's what this does. This is coarse. The dial here is coarse adjustment, and then this dial in the front is your fine adjustment. So that's what I use for punishing the battery and seeing what it will take. Let's take a look at some key points that I think are important for the marine environment. So first of all, let me just point out these arrows are what I want to talk about. It says standard charging voltage 14.6. Do not do that. The battery won't let you anyway, so there's no point in going to 14.6. That is your maximum charge voltage, and I wish they would state that right here, not standard, because it's an error in their manual. So shipping capacity 50%. This is not a Wattcycle thing, guys. This is an FAA thing. This is a federal rule. You cannot ship lithium-ion batteries at more than 50% state of charge of this size. So let's take a look at serial and parallel connections. You can do 4 parallel, 4 series maximum. Pretty much standard in the industry unless you got batteries that communicate together. And these do not support external communication, Bluetooth support only. So the batteries are IP67 or IP65. I'm not quite sure because I need to pose that question to Mike. I've seen in the literature 2 different ratings of IP65 and 67, but regardless, it's very well sealed. I see no problems with it in the marine environment. The batteries also do meet UL, so that's a key point. ABYC requires that, and they do meet UL. So here's where I'm pointing out the 14.6. Don't do that because the manual is wrong. As you can see, I reached out to my contact and I said, hey, the manual and the FAQ are in disagreement. And they wrote back, oh yeah, well the charging voltage is 14.4 plus or minus 0.2, which puts you at what I would recommend, which is 14.2, which is what Victron recommends, which is just about anybody in this industry recommends as a max absorption voltage that knows anything, that's actually smart, and they care about the longevity of these cells. 14.2 is a fine voltage. It will get you to 100%. Hell, 14 will get you to 100%. But the cells balance at 14.1 or 3.4 volts, which is 13.6 volts as a pack. But if you have a 30 volt 30 millivolt difference between the cells, the highest and the lowest. Balancing kicks in at 3.4 volts. So the balanced current on this battery is 50 milliamps, which for grade A cells is just fine. Here's some key points that I just want to touch on. They don't want you paralleling these with lead acid batteries or other lithium-ion chemistries. They also don't want you connecting them with other brands. And the ABYC defaults to the battery manufacturer's manual. So pay attention to these things if you get an insurance survey coming up. They don't want you putting batteries together that are more than 3 months or older. Don't worry about that. You're not going to have a problem. But, they don't advise it. That's just a CYA on their part. So the battery does have overcharge protection. Now, what is overcharge protection? Let's talk about that a minute. About, maybe 2.5, 3 years ago, I started seeing batteries come into our shop that were turning off the charge FETs when the charge voltage was up above, say, 14, and the charge current was very low, meaning the battery was basically full. But prior to that, there's no BMS out there that I knew of that would actually turn off the charge FETs. Maybe there were some, but now it's pretty common in a lot of these batteries. So what happens is when the BMS determines the cells are full, it stops the charge FETs from allowing charge current into the cells. It just turns off the charging, that's all. And it happens at a very low current, and you're still attached to the loads. So if you have any loads, you're not going to get a spike because the load, that spike is going to go to feed the loads. So charge current is turned off. The worst thing that you're going to see is maybe a high voltage alarm if you're charging from an old school inverter charger, which is low frequency, or a quality inverter charger, which is low frequency, because it uses a big toroidal transformer in there. And you might see a brief voltage spike, which could set off an alarm. There's nothing to worry about. That's all it is very brief spike when the charging shut off. If that's, again, if you have no loads and the charger can't dissipate that into the loads. But if you're just charging the battery, you may set off a high voltage alarm. That's all. So let's take a look at the BMX warnings and protections. Standard charging current and maximum charging current. What's the difference between the two? I can charge this battery at 200 amp. It says so. No, that's your maximum. And the reason for that, that's a very brief time that you can do that. And the reason for that is because, remember when we talked about the BMS and balancing and passive balancing and those resistors needing to burn off current? So that's why. Because at 200 amps, they can't burn off enough current or heat to let the other cells catch up, and you'll have a shut off at a low voltage and a high charging current, which will lead to a bad voltage spike. So the recommended charge current is 0.2 C, or 20% of amp hour capacity, which on this battery is 62.8 amps. And they've announced a new 314 amp hour ultra, which is also 0.2 C. So even though it's got a bigger BMS with a 300 amp discharge, the charge current is still 62.8 amps, which is 0.2 C. So that's all. Maximum discharge, 210 amp plus or minus 10 amp. I found out on my battery, it's 210 amp plus or minus 5, but that's well within the spec. And the spec's pretty accurate. Let's take a look at what I got from this battery when I discharge it. Again, this is the West Mountain Radio CBA 5 Pro, and delivered 330.5 amp hours. And as you can see, it cut off. I set it at 10 volts. In my personal batteries, I set them at 11.2, but it cut off at 10 volts, and then this is a rebound voltage. I'm just going to point out something, guys, that a lot of people aren't aware of, and I don't see a lot of people talking about. So this rebound voltage, it cut off at 10, but then it rebounds to 11.3. Now, at 11.3, this battery is going to restart. It's going to turn itself back on. And so if you have a parasitic load and you've discharged your battery all the way to the cutoff, and then it rebounds, and then it turns back on, it's going to repeat. And pretty soon, you get to a point where it can't rebound, and the battery is disconnected. That's why you see people have to jumpstart their batteries. So if your battery is low, you got to remove all your parasitic loads from it so it doesn't do that. And that's the reason. You can still over discharge one of these things, especially if you have a very low parasitic load. That's all. So let's take a look at the construction. Again, my whole point in this series is to make sure you're getting a good value for your money. And the construction is something that a lot of people can't see because it's inside a plastic case and they all look the same. They're all the same shape, different sizes, but they all look the same on the outside. Now, this is one of Wattcycle's biggest competitors. In fact, it's the #1 selling brand on Amazon. And this is their idea of building a drop-in battery. Cheesy and cheap construction. Now, let's take a look at the cell module. Here's our 4 cells. What they've done is they put them in these little plastic alignment trays, I guess I would call it. They have no rigidity on the end boards. They're just plastic. They're not strong. They wrap it with pallet tape, which can bow out on the ends. And then they take the BMS and they tape it to a piece of PCB material, which is fiberglass, and they glue it to the cells. And then they tape it to the fiberglass board, then glue it to the cells. They don't use a case that's designed to fit the cell module. They just stuff a little foam in there, and that's how they take up the space. Now picture yourself 80 miles out at sea on a sport fishing boat, and a storm's coming, and you're trying to head in, and it turns up to 5-6 foot seas, and you're trying to push 20 knots. How do you suppose this battery is going to hold up inside that case? It's going to be bouncing around, and it's not going to do well. The other thing that I don't like about this construction, let's take a look at the pads first. Again, this is a 200 amp BMS, and this is where each of these wires goes to the outside of the case here, and they all go into one terminal up top, just like they do down here. You can see they got 3 wires stuffed into one terminal on the battery negative side, and then they divide out into 3 on the printed circuit board of the BMS. But these pads, these horseshoes here that it screws to, are very tiny. Look at the surface area on that, nothing. And I would never do this to a customer. We would have never stuffed 3 wires into one terminal, even though it's allowed. It's just not something we do. It's cheesy. You'll never get a seal here if you're trying to heat shrink it. And it's just 3 10-gauge wires on a 200 amp BMS. Even though these are silicone wires, it's just, why do they use a 4-gauge over here? Because they chose not to bust these together and use an actual properly sized wire. That's why. They're cheap. So now, why do we need good construction? Well, here you go. Lithium iron phosphate cells expand and contract when you charge them. If you've not properly constrained the cells, meaning a cell compression module, which is what Eve, the manufacturer of these cells, recommends, you can ruin the batteries in short order. A lot of manufacturers don't pay attention to that, and they cheap out on it. Let's take a look at the Wattcycle module here. This is the 314 module. So this is the battery module pulled out of the case. And what we're looking at here, remember I just talked about the 3 small wires and how they did all that? This is how Wattcycle's done it, and they didn't always do it this way. I mentioned to my contact there that I didn't like the 3 wires stuffed into the cell and it's sloppy and blah, blah, blah. So when they sent me this 314, look at what's in it. Copper bus bars connecting to the B- and the P-. P- just means power out to the battery. It goes to the outside of the battery lid. And then this comes from the B- of the battery module. This is your positive output. And then input to the BMS and then output. A BMS always interrupts the negative. So here's your Bluetooth module. And then these are your temp sensors here. And it's all well built. This BMS is elevated in the air. So it's got heat sinks on the bottom and the top. And air can get underneath it. It's a very good design, not just glued to the cell module. Another point, remember I was talking about those little horseshoes where the BMS goes to the printed circuit board? Take a look at what Wattcycle's done here. Look at the surface area on that. It's pretty impressive. Excuse my voice, guys. I shouldn't even be talking, but I am. So this is a good quality design here. The wave soldering has got plenty of surface area. It's well done. It's well done. This is your B- side. The P- side is the identical thing. It's the same. Here's the wiring that goes to the Bluetooth module here, and they put sealant on it. I think it smells like polysulfide, but it could be polyurethane. I don't really know. And then these are your balance leads, And again, these wires here go to your temp sensors. We see temp sensor 1 and 2 here. Temp sensor 1 was here, and then 2 was way down at the other end. So they've spread them out inside. The BMS also has a temp sensor inside it and one on the FETs. So we got 4 temperature sensors in this thing. Here's what we're talking about with cell compression. Now, first of all, these are our 4 cells, and in between each cell is an isolator pad that keeps these cells from vibrating against each other and wearing through the blue wrap. We got 3 drawbars on each side at the top of the bout so that it's drawn tightly together and won't allow the cells to move. And then these are the end boards. Remember I talked about the plastic end boards and how they have no rigidity? These end boards have plenty of rigidity. They folded them over at the top and both on the sides to give it good rigidity. And here I've flipped the battery over. We're looking at the bottom. It's also cross-strapped. They've stamped this piece out, folded it, and brought it up. And then the cells drop in, and then they put the 3 drawbars on each side and across the top and hold it together. Another nice touch that I really like about this battery, you're getting a lot of value for the money here, guys. This is the underside of the lid for the 314 amp hour battery. They're using braided flat cable. This stuff is ungodly expensive. At least it is in this country. Maybe in China it's cheap. I don't know. And they put very heavy duty heat shrink on it so nothing's going to short out. They've even put caps on the nuts in here inside the battery. And as you can see, it's tinned cable. So it's tinned oxygen-free copper. Expensive feature, but very nice. It makes for a nice, neat installation. Also, I just want to point something out. I've seen a couple guys in the Wattcycle group say that the battery is not sealed because they're not seeing any glue squeezing out along this point here. Keep in mind that the seal on this lid is way down in here. And then you have about 1 inch of an overlap. It's like a shoebox. This drops over and the seal is way up inside. It's like right here. So this is where the glue goes. Yes, some of it drips down into here, but you should, this is not the seal right here. That's not the seal. The seal is up here. I hope this helps point that out to some people. Size and weight, awesome. One word. Okay, what we've got here is we've got 200 amp hours of Odyssey Extreme AGM batteries, and they're 77 pounds a piece. However, they're $550 a piece, and you can only use 50% of the battery. Sure, Odyssey says you can go to 80%, but you're only going to get 400 cycles, 400 lab cycles, I should say. You will never get 400 cycles going to 80% depth of discharge in the real world because lead acid battery sulfate, including TPPL AGM. So you're paying $1,100 for batteries that you can only use half of. So you're carrying one battery around as complete dead weight. I call it dead lead. So this battery is just dead lead. You're only using this one. Or, you're using 50% of both, but you're only using 50% of it. This whole 314 amp hour battery, not much bigger than the Group 31 and not much taller, only weighs 60 pounds. You can use 283 amp hours. So a whole other Odyssey battery, another 77 pounds, would only give you 300 or 150 usable. Think about that. And you can go to 90% depth of discharge. Now, I say 90% for the marine market. Stop there because you want a 10% cushion just in case you get into an emergency. But you have to decide for yourself what you want as an emergency cushion. You can do 20%, you can do whatever. Don't worry about cycle life. These are going to outlive you with the charge protection. They'll outlive the length of your boat, let's put it that way. Honestly. My own pack is 16 years old. And it still delivers 100% of its capacity. 16 years old. Now this Odyssey Extreme, here's the actual height where the lead post is. This is about a 3/4 inch difference. That's it. So this battery is 3/4 of an inch taller. So if you got the height, you'll get a ton of capacity where you would have to have massive, massive lead acid bank, to do the same thing. Okay, let's take a look at the Bluetooth app. And I'm going to be perfectly honest here. It needs some work. And I'm going to include these comments for Wattcycle too because I think they can do a lot better. They are a company that listens. I got an email from Mike when Will Proust released his video showing that the 280 amp hour cells that they called the 300 amp hour battery were actual Eve 280 cells, not 300. And he said, do you think it's okay even if the battery is tested 300? I said, yeah, you're misleading the public. Those are 280 amp hour cells. They're not 300 amp hour cells. And I said, but Eve does make a 314 amp hour cell in the same exact size. I said, maybe you guys want to look into that. And then sure enough, look what they've done. They listened. They changed the other battery to 280 amp hours publicly. They ate crow, and they even refunded some people some money for the misprint. So they do listen. They also have updated the app. They used to use a different app, which was just generic. And now they've got a Wattcycle app. However, and I'm going to make these points just, I think what they could do, this is just nothing more than an advertisement up here for Wattcycle. You've already bought a Wattcycle battery. This doesn't need to be here. The 100% could be much, much smaller. This little pulsing thing here that shows you when charging or discharging is occurring needs to be smaller. In fact, you can make the 100% blink, and that would tell you that something's going on. But you can already see down here with your current screen what's going on, so this doesn't even really need to be here. Our pack voltage is here. If you want to see temperature, this is only your environment temp here. That's all that is. So it's showing you inside the battery temperature right here. If you want to see the temperature, you're going to click on T, and then it will open this, and then you can see your environment temp, your MOSFET temperature, which is the BMS temp, and then cell temp 1 and cell temp 2. So, however, all of this stuff could be on the main page if they maximize the real estate. This is wasted real estate right here. It doesn't need to be here. Everything could move up, and it would be great. So I'll point out here that if you want to get into the voltage screen, you just tap on V, and then it opens this up. So the important things that we're looking for here are average cell voltage is really not critical. Who cares about that? What we're caring about is the differential voltage, your VDIF, or differential voltage as Wattcycle calls it. And that is the difference in voltage between your lowest cell and your highest cell. Right now my battery is at 0.006, which is tremendous. That's really good. So I renamed mine 300 mini, and you do that by tapping on the pencil, then renaming it, but keep in mind that only renames it in the device you've named it on. So that's for my iPhone. When I open up the iPad, I got to rename it again. And I recommend putting a sticker on each battery. So if you got 2 or 3 of these, name them 300 mini 1, 2, 3, and then put the sticker on it so that when you connect to it, you know exactly which battery you're connecting to. That's the best practice right there. So if we want to get into this screen here, we get out along the bottom and we see Bluetooth. That's where you connect to your battery. Your dashboard is this page here. And then the About page, you click on that. And then that takes you into Settings. Click on Settings. And then here are your settings. Now, I do not recommend that you guys change any of these. My battery may not be locked because I'm a partner of theirs. I don't know. But I can go in there and I can change these. I do not recommend it. In fact, the only one that I would recommend changing is I put mine at 11.2, so I click on the enter and I put 11.2 and then I hit set. Because there's no current, no energy left beyond 11.2 anyway. So 10 volts, you don't need to go there. Why go there? So I set mine at 11.2. Don't touch any of these. Leave 14.6 as your max charge voltage and you'll be fine. All right, we're going to take a look at the performance of this battery and see how it did. Right now I'm applying a 200 amp load, and I'm going to increase it because I want to see the battery disconnect. And I know mine disconnects at 215 amps, which I'm getting to. I'm adjusting the fine dial right now. There I'm at 215. And what we'll see is the battery monitor is going to disappear here in a minute. And that means the battery has protected itself. Now it takes about 60 seconds for it to come back on, so I snipped that part out of the video, and there it comes, it's back on. But what's important is that it came back on into a 20 amp load. So that's good. The BMS will resume where it left off, and it won't interrupt your charging. So here I'm testing the heat protection to make sure that the battery shuts off on over temp. And again, we're going to see the battery monitor just go blank because I'm heating it so hot. There we go. Now this again takes a few seconds to come back on. There it is. And again, it reset into a 20 amp charge current. I just got to switch pages on the Cymarine. 20 amps. So now what we're going to look at is cold weather protection. So discharging at 200 amps because the battery was at 100%. Ignore this screen here. This is just for voltage and current. It's not calibrated. So as we can see, I'm now down to 96%. Turned off the load, and I'm going to turn on the charger right now. Charger's on. There's our 20 amps of charge current. And next I'm going to put the temp sensors, both of them, into this glass of ice water, brine solution. And right now it's currently at 32 degrees. I'm going to drop both temp sensors in there. And what we're looking for down on the bottom is for the charge, the big blue boxes on the bottom of the app screen. The charging one, the one on the left, is going to go light blue, and that means the charging has been turned on. There it is. Charging is off. So the battery has done its job. It meets all the performance metrics, and it's a hell of a value. $549 is a killer deal. I can also offer you guys a discount code. You just have to email me, marinehowto@gmail.com, and I will send you the link and the discount code. I forget what it is, but it's a pretty decent discount code. And you've already got a $549 battery at a very affordable price. So please help me grow and by liking and subscribing. I'm done typing with one finger and I'm trying to move to video. My YouTube channel has less than 1,000 subscribers. Let's blow that up, guys, and help me out. Take care. Have a good time. Bye-bye.